Hello, my name's Frank, and today we're going to study exponent review number 2. Now, what came earlier was the exponent derivation, where we derived all 5 rules. Then we did exponent review number 1, which was basically the first 3 rules, where you multiply and you add the exponents, where you raise the powers and you multiply the exponents, and when you divide, you subtract the exponents. Today, we're going to deal with the 4th rule and the 5th rule, and then we're going to do a cumulative review. So we have 9 problems for you. So let's look at the first example. 7 raised to the 0th power. Now, in the derivation, we proved anything to the 0th power is 1. So 7 to the 0th power, using the 4th rule, is 1. And that's an interesting proof that if you look at the derivation, I think you'll agree. All right, so that's the first example. The second example is x to the 0th power. Well, that's basically the rule. We wrote it in the rules as a to the 0, but x is something, so x to the 0 is 1 likewise. Okay, our third example. Now, sometimes when a student sees something to the 0th power, they automatically say it's 1. But I caution you, the only thing being raised to the 0th power is this x. So that circle is 1. But remember, you have to multiply by 5. So in this case, the answer is 5. So be very careful with that example. Now, just to show you another one right under it, if you were to write 5x and then raise it to the 0th power, now this is different. Now, the whole thing's being raised to the 0th power. So this whole thing, it would be 1. So notice the difference between these two. Okay, students frequently have difficulty here. That's 1 times 5. This whole thing is 1. All right, our negative exponent rules. Now, we derived this last time, fairly interesting derivation. What do you do with a negative exponent? Well, the rule says you take it downstairs in this case. So what our rule stated was this would be 1 over 4. You write the reciprocal, and then you raise it to the positive power. Now, 1 times 1 times 1 is 1. 4 times 4 is 16 times another 4 is 64. So this is 1 over 64. Okay? All right, introducing variables with negative exponents. So if you were to see this problem, most rules in mathematics will say answer without negative exponents. So you'll see a negative exponent on the y, and you'll see a negative exponent on the z. But you see a positive exponent on the x. So the x stays to where it is. But a negative exponent, I call it like an escalator. If it's up, you take it down. So y to the negative 3, since it's a negative exponent, it would go downstairs, and you'd raise it to the positive power. Z to the minus 1, it would go downstairs, and it would be z to the first power. You could put the 1, but you don't have to put the 1. So that's your call, if you want to put that 1 there. So most papers, most teachers, most testing will ask you to remove the negative exponent from the problem. Okay, the next problem can be done 2 different ways. Way 1 is just to leave it and apply the power exponent. Remember, that's understood to be a 1. So the power exponent says you would multiply the 1 times the negative 2, and that would leave you negative 2. You multiply the negative 2 times negative 2, and that will give you a positive 4. And then you multiply the 3 times the negative 2, and that would give you negative 6. Now, we don't want negative exponents in our final answers. So we got to get rid of that negative 2. So since it's up, we take it down and raise the power to positive 2. We leave this to where it is. Now, you can leave that 1 or you can erase that 1. It just took a placeholder. But now the placeholder is going to be x to the 4th. Because that's a positive exponent. This goes back down because of the negative exponent, so it'd be y to the 6th. Now, you wouldn't go into the store and say, I want 2 square things, even though it's right. If you want 4, 2 to the 2nd is 4. So there's your answer. Okay, so that's the first way, and I think that's the easiest way to do that problem for you. Reinforce the rule, the power rule. Okay, so that's getting rid of the negative exponents. Now, the last 3 examples I gave you is something that is seldom taught in Math 1, but it is there. But it's different. And this time you have exponents, which are variables. Well, you still apply the same rule, but look at the difference, look at the rules here. So this is like accumulation of our rules. So let's start off with 4 times negative 9. We know that. A positive times a negative is a negative, and that's negative 36. Okay, rule 1 stated that if you have the same base of x, you add the exponents. So if you have 1m and 3m, that would add up to 4m. Divided by 6x to the 2m. Okay. A negative 36 divided by 6 is a negative 6. Now, what did the division rule say? We subtract exponents. So what's 4m minus 2m? 4 minus 2 is 2. So there's your answer. I like to give problems with variable exponents just to let the student reinforce it and realize it's no different than if they were numerical exponents. Okay, so that's an interesting problem. Okay, let's look at our next example. We have variable exponents. This time we have 2 variables, m and n, and then we have negative exponents to that. So think of the rule, the power rule. We multiply exponents. So we would multiply a 5m times a negative 3, and that would be negative 15m. We would then multiply on the y the negative 2n times the negative 3 and get 6n. Now, we don't know if m or n are negative or what, but we want to just get rid of this negative for now. So remember the rule on negative exponents. If it's up top, you take it on the bottom. So this x goes on the bottom and we raise it to the 15m power. And this 6n, everything was fine, we leave it to where it is. And there's your answer. I like to see students do this because when they get it, they say, hey, this is pretty cool, where they can use numbers, variables, or a mix. And then our last one, try to make it a little challenging for you, hope I did. Let's look at this problem. Now, if I gave this to a class, somebody would use the power rule right at the beginning. Multiply this by 2, this by 2, and this by 2, and likewise that. And that would be great. Other students would say, you know, I'm going to do the division first and then raise it to the power. It makes no difference. So in this case, I think I'm going to stick with the division just so I can reinforce that again. And try to get you around some careless errors. if you subtract these two exponents, now, if I ask a student to do that, sometimes they do it quick and they'll make a careless error. But if I say it slow and write it on the board, and I go, what's negative 2n minus n? So now look at that. And then they'll realize that would be negative 3n. If they did it in their heads, they may not get that. So be careful. Okay, now B. If I ask them to subtract 3m minus 6m, usually we'll get that. 3m, take away 6m, is negative 3m. And then on C, if I say it slow, 4p minus a minus p, they'll realize that that's going to be turned into a plus, and they'll say 4 plus 1 is 5. So that's inside the parentheses. So I caution you to write them subtractions out slow, and then we're going to raise it to the second power. Okay? Now, so notice we used the division rule. Now we're going to use the power rule. The power rule says you multiply the exponents. So negative 3n times 2 is negative 6n. Negative 3m times 2 again is negative 6m. And 5p times 2 is 10p. So there's the power rule. And our last rule is the negative exponent rule. How do we get rid of a negative exponent? We take it down to the bottom. So this a, and we change the exponent to 6n. Likewise to b, 6m. And this is fine to where it is because it's positive, c to 10p. Now, so what we did is we did our last two rules, our zero exponent rule and our negative exponent rule. And then I tried to do a cumulative study where I put the exponents as variables to recognize it. It's the same. You can make these exponents more than one term. You could make negative 3 plus x there, or negative 3 plus a variable, and you can continue and continue, and that's what you'll do in your higher level math courses. All right, so I hope you found this informative. I hope you found that the last one's pretty interesting and challenging, and stay tuned for the next lesson.